Okay, so then last video we looked at this picture, and we saw that these two events were not mutually exclusive. Let's talk about a different experiment. Toss a single coin and observe the result. So if you toss a single coin, we ask, what are the simple events? What are the things that can happen? You can get heads, or you can get tails. So we call E1 observing a head, and E2 observing a tail. So the event E1, the simple event E1 means that you observed a head, and the simple event E2 means that you observed a tail. Then we ask, the next thing they ask is, what's the sample space for this experiment? Means, what's the set of all the simple events? And that's E1 and E2. So that's the sample space. Or more simply, the sample space is heads and tails. Okay, so that's an example of a sample space. Okay, another experiment is record a person's blood type. And so what are the results that you can get? You can get someone has blood type A, B, AB, and O. Apparently that's the only 4 possibilities. So these are the 4 simple events, and the sample space is the collection of all of them. So it's here. What can happen? In other words, the sample space is what can happen if you record a person's blood type and write down what it is. So you can it's either A, B, AB, or O. So the sample space is the set of all the possible outcomes. Okay, they say sometimes you can use a tree diagram to maybe make it easier to figure out what the sample space is. Some experiments can be generated in stages, and the sample space can be displayed in a tree diagram. Each successive level of branching on the tree corresponds to a step required to generate the final outcome. So here we have sort of a little bit more complicated experiment, because it's not just observing the blood type, but they're also recording the person's blood type and RH factor, which I have no idea what that means, but they're going to record the RH factor. List the simple events in the experiment. So maybe we can use a tree diagram to do this. They say for each person a 2-stage procedure is needed to record the 2 variables of interest, so the blood type and the RH factor. The tree diagram is shown in figure 4.2, so let's look at that in a second. So here's the answer before we look at the tree diagram. You can have blood type A and plus. RH, I guess, is plus or minus. You can have blood type A and minus. You can have blood type B and plus, blood type B and minus, and so on. So it's actually just what? These, and then with a plus or a minus on each of them. So there's 8 of these. But let's see how you'd use a tree diagram to do this. So first you'd write blood type. Usually you start from, you write some, you just have an origin over here, and then you write the steps. So the first is to talk about the blood type. So we say we can have A, B, AB, or O. And then once you have A, then you talk about the next step, which is the RH factor. And given that it's A, you have 2 possibilities for the RH factor, can be plus or minus. Given that it's B, you have 2 possibilities, plus or minus. Given that it's AB, you have 2 possibilities, plus or minus. So we get A plus, we get A minus, we get B plus, we get B minus. And so this tree diagram can help us to write out these different possibilities, or different outcomes, or different simple events. So here they are, and we can also write it like this, right? The sample space looks like this. There are 8 elements in it.